Yesterday in our lesson talking about angle relationships with transversals, we were working with non-parallel lines. Notice that these two lines are not parallel. Parallel means that they are like a set of railroad tracks. They're equidistant apart along the exact length. And so what we noted yesterday was the fact that none of these angles are congruent except for those that are vertically opposite. So the vertically opposite angles would be congruent, but no other angles are, because these two angles, which are vertically opposite as these are in this diagram down at the bottom, these are equal because this angle is supplementary to angle B and this angle is supplementary to angle B. But these are the only angles, the vertically opposite angles, that are of the same measure. Corresponding angles are not the same measure, neither are alternate interior angles. So the only angles when we have non-parallel lines that are equal to each other or equal in measure are our vertically opposite angles. Now today we're going to talk about parallel lines and transversal relationships. So this time our lines are parallel. They look like railroad tracks. Now, when we talk about parallel lines, everything changes. Vertically opposite angles have the same measure. So that means that this angle is opposite this angle, and they have the same measure, as do these two, and these two, and these two. Corresponding angles also have the same measure. So when I take my corresponding angles and put them in here, we see that this angle is congruent to this one. Now the corresponding means they occupy the same position, so they're both on top of the parallel line. And if we need a little way to see how we can decide if these are corresponding or not, when we have corresponding angles, we're looking for the F. So if I was to set this in here, you would see that this is sort of like an F, because the F goes here and here. So when I'm looking for corresponding angles, I am looking for the letter F. It doesn't always have to be upright. It could be upside down. But these two angles have the same measure. The same with alternate interior angles. Remember, alternate interior angles are on opposite sides of our transversal and inside the parallel lines. Well, when we take a look at alternate interior angles, we are looking for a Zorro or a Z. So if I was to highlight this path, we would see the Z for Zorro. So when we look for alternate interior angles, we're always looking for the Z. It can be this way, it can be this way, it can be like this, it can be backwards. It doesn't matter as long as you can make a Z. Now we had same side interior angles, so now I need to flip this angle over here. So same side interior angles are supplementary. Now we don't see a Z or an F. Here we see a C. So if I was to highlight this in blue, you can see that this makes the letter C. So we know that these two angles have a sum of 180 degrees. So same side interior angles and same side exterior angles, the same thing is true. They too are supplementary. So if I was to add this angle to this angle, they too would equal 180 degrees. So let's just recap what we learned. Vertically opposite angles are congruent. They are here and here. Corresponding angles have the same measure, so they occupy the same position relative to the parallel line, and we're looking for an F. Alternate interior angles have the same measure, and we're looking for the Zorro. Same side interior angles are supplementary, so we look for the C. So that means that this angle plus this angle is equal to 180 degrees. And same side exterior angles are also supplementary. And this only happens when we have parallel lines cut by a transversal.